methods that we have, in one way they enable innovation. And on the other hand, they lock us into that paradigm. So at the same time as they are great for innovation, they may also exclude some types of innovation. That's on the one hand, and we have seen how technologies normally develop over time, even though we know that we should be very careful when we look at those graphs. On the other hand, we have looked very briefly into the customer and market side of innovation, where we see that, well, it takes time, there are limitations, there are lock-ins into that as well, and that also it's dangerous to think of all customers as though they were the same and had the same preferences. So with this in background, I think we can now turn into a little more management-oriented questions here, because these things are really giving us the overall picture over time, but they don't give us a lot of managerial help. It's good to know that, okay, this is how it actually works normally. So what did they do? Well, they realized that actually if they took the river, they deviated it into the city and let it fall down into the basements. They dug out the houses so they could get 3 to 4 meters of falling water. That's not a lot of power. So what they specialized in was actually making mechanical parts that rotated with very, very limited losses due to friction. They are fantastic at making rotating pieces since the 13th century. That's why they keep on making rotating pieces in the packaging industry. And they're best in the world in that. When Tetra Pak looked for a place to put their R&D lab, apart from Lund, they put it in Modena, just next to Bologna. And of course, all the high-performing sports cars we know of, Lamborghini, Ferrari, they are from this area. They're very good at rotating pieces, actually. Rotating very fast, actually. Yeah. So sometimes we see that we get these trajectories, we get locked into, and it's impossible, of course, to suggest to an engineer in Bologna to have a linear movement. It all has to rotate. Now, these are extreme examples, but actually we can see that we often get into this, that we learn something, and then there is an exponential development, but actually the more we do it, there's an exponential development of time or cost or whatever. So if we are very good at making rotating pieces, we will not suddenly just jump over and make linear ones. And of course, this goes also, for instance, for quality, we improve it exponentially. So these learning effects lead to a lock-in. We get actually trapped into a certain trajectory. Now, let's come back to this network externalities. I think we need to spend a little time on that to understand really how that influences industrial dynamics. Now, network externalities is an economic concept saying that the value of a good to a user increases with the number of other users of the same or similar good. What does that mean? It's actually a little counterintuitive, because economists normally talk about scarcity of resources. The more rare something is, the more scarce it is, the better it is. I mean, diamonds, they're scarce, they're not very easy to find, they're valuable. And then suddenly we come up with an idea how we can produce ideas with high pressure and carbon. That's basically how you do it. And suddenly the price of diamonds drop because they're not so rare. You know. Here we're talking about something completely different. The more there is of something, the more valuable it is. So first reaction of most economists here is, what? This is a strange beast. But let's take an example to understand it. Let's take the phone. Now, who invented the phone?
Graham Bell.
Graham Bell, Alexander Graham Bell. Any other bits? No, it was not one of those. There are many other things. Many other things. So if you should ever guess, go for Edison. But in this case, it's unfortunately not Alexander Graham Bell. Sorry, last Magnusson. No, okay. This is also part of history that you should know. Actually, Alexander Graham Bell did not invent the phone. The Americans claim, but if we look at the evidence, he was an Italian. Antonio Meucci. He actually developed it a couple of years before Alexander Graham Bell. He also applied for a patent in the US. But he actually didn't mention the most important pieces. I mean, the electromagnetic conversion into sound. That was not written explicitly, so he didn't get that patent. instead, Alexander Graham Bell was smart enough to mention that in his patent application, so we got it. Alexander Graham Bell, however, he patented it not in all countries in the world. He only took the ones that he thought were important. So he actually patented it in Norway, and at that time there was a union between Sweden and Norway, so he thought he had covered those two strange countries up north. Unfortunately, he hadn't. And that's why Lars Magnus Ericsson realized that he could build phones without any problem. Now, coming back to this, if we just forget about history here, and this who actually did what, say Alexander Graham Bell is sitting there with a phone. He has one phone. What's the value of one phone?
I remember this from when the mobile phone came. I was like, I have one, but who am I going to call?
Ah, well, you could call it fixed line.
Yeah, you could. That was not really.
No, you didn't do that. No, there were many interesting stories when we first got our mobile phones. How we behaved. We always asked first, "Where are you?" As though that was important for some reason. Who cares? No, it's interesting. But let's get back to it. The value is zero. Almost. I mean, we can use it for some purposes. If we have a lot of paper here, we can put it as a weight on top of that, or we can, if we have nails hanging out of the wall, we can use it as a hammer because it's probably heavy and hard. If we have two phones. Now, if you have a friend who also has a mobile phone, then suddenly there is a value. We all remember when we were kids and we had walkie-talkies and we walked around, and that was with one, maybe two other people, I don't know. So, of course, if we then have 1 billion phones, enormous. The value is fantastic. And this is, of course, all the reasoning when you have heard all these presentations by Ericsson. We connected 1 billion places, that was how many fixed telephones there were in the world, to now we are connecting 7 billion people, individuals, and we will connect 60 to 70 billion things. There is value in that, if we understand the concept of network externalities. Of course, there are a lot of other examples. Railways. It's very nice to have a railway between Gothenburg and Stockholm, but it's even better if I can go to any place, wherever I want in Sweden, via the railway. And video game consoles. Don't know if any of you are avid gamers. I just had a lecture this morning with my students, and they knew everything about video game consoles, I can tell you. There are a few big players here. Sony, Microsoft, Nintendo, for instance. The interesting thing is if we take them and we look at their statements about market shares, it will add up to more than 100%. Why? Because they want to look big. And why? Well, it's basically because of the mechanics, the mechanisms of complementary goods and an installed base.
It's also the reason actually you have two consoles at home. One of each.
One of each. Should have that. That's a good point. What we see is that we have all these complementary goods today, or complementary services for that sake. We can take video games. In order to play a video game, we also need the game, not only the console. And even though Sony and Microsoft, they are actually reasonably good at developing their own games nowadays, put a lot of effort into that. Many of the cool games come from gaming companies, with weird people making really weird stuff. And when they sit down and say, for whom should we develop the next cool game? They of course look at, how big are they? How big is Sony? How big is Microsoft? How big is Nintendo? Because they want to develop goods for the biggest one first. And what happens is that if you are big here, you will get more complementary goods, which will actually lead to more people buying your console. And then we end up, of course, in the very, very clear example we all see, Android and Apple. We have very few cases. It's very difficult for someone today to break into that market, because who will develop the apps? So even if Nokia would make a fantastic smartphone nowadays, they would also have to encourage a lot of people to develop apps in order to be competitive with Android and Apple. Now we see that a lot of firms are focusing a lot on this. Film, you have talked probably a little about Kodak, if Christian has been here. Didn't he mention that, or he talked only about Hasselblad? Kodak was basically only making film. That was how they made money, so they made cameras to sell more film. This is, of course, a classical example, videotapes for video cassette recorders. You probably have heard two competing standards. On the one hand, VHS, pushed by Philips and Japanese Victor company, JVC. On the other side, you had Sony and Betamax. Betamax had higher quality, image quality, slightly shorter playing time, but technologically seen, it's better product. Nevertheless, the standard became VHS. Why? Well, because VHS players convinced the video rental companies to go for VHS. And then, at least in Sweden, I could use my video cassette recorder in two ways. Either I could record the fantastic programs of Swedish state-run television, channels 1 and 2, with Disney once a year, and I could watch that over again. Or I could rent a movie. So of course the value for the users here was enormous if they could actually get VHS compared to Betamax. And of course, today we see this most clearly in the apps, that the value here is not only in the product itself, the installed base, but very much in the complementary goods. And this actually locks us in. We end up with a platform, and it will be very difficult to actually challenge that platform. It's very difficult today to challenge Google with Android and Apple in the mobile phone business. And they are actually the two who are making the money there. There are many other players who are trying to compete in some one way or another, but very few who make money. Because what we see is, of course, that if we have this kind of a system where we have a platform with complementary products, we have two different ways of competing. If we assume that we have an existing technology, and then value would be a function of three things. It would be a function of the mere technological utility of the product, how well does it work, but it's also related to how many others have this type or similar product, and how much complementary goods is available. Now, if this is the situation, and it is in very many industries, we can compete in two ways. One is if we say we will beat this with a standalone, better product, a new technology that actually in itself has a higher utility than the old ones. Can you come up with an example where someone has actually tried to do that? I can start with a case where it didn't work. Nokia. Nokia wanted to do everything themselves. They made the best phones. No doubt. They looked at the iPhone and said, this is a poorly functioning phone. Yes, as a phone, it's not as good as the best Nokias were. But it's much more than that. There is other value from these complementary goods, or the apps, for instance. But Nokia wanted to do it themselves, and unfortunately, they didn't make it. But there are other cases. If we take this one, Macs. If you ever used a Mac, especially a long time ago, it's a weird sensation because all the normal software is not there. Now it is. Now it's compatible with Microsoft. But when I started using it in the late 80s, sometimes as a student, I was studying at two different universities, and at one they had Macs, and at the others they had PCs, and you didn't have laptops, so you had to use what was there. And then when you came to a university where they had Macs, you had to relearn everything, and it was really burdensome. But they tried to beat Microsoft and Intel and their the PC setup with providing something that was just better in itself. And we can debate whether it is. We don't even have to agree. Some people think it's better. Some people thought that, yeah, it's a nice operating system. It doesn't break down all the time. I don't get this blue screen. I don't get any viruses. That's nice. And then, of course, some people actually like the software they had developed themselves. Most people probably not, given that they have now allowed us to use Microsoft stuff. Of course, we know that this was a very difficult strategy because initially it didn't work. Only very few people actually liked this, and Apple was close to bankruptcy. And Steve Jobs got the opportunity to buy it at a very cheap sum, $1 I think it was. Now, so this is a tricky one, but this is more frequent. What we then say is, okay, we accept that we try to compete with the same installed base, the same complementary goods, we just marginally increase the technological utility. Now, here you can come up with examples, I'm quite sure. We can take almost all Android phone manufacturers are here. They accept this. We play with the Android system, and then they try to improve it. So Sony tries to have a little better camera. Samsung has a slightly better screen. And hopefully that makes the difference. And unfortunately, the same does also burst into flames, but that's another thing. But they are trying to compete inside this installed base and availability of complementary goods. There's of course not one way that always works. We have seen that there are examples where we fail with this and where we succeed, and the same with this one. Because in the end also, if we take Samsung, yes, they're the market leader in mobile phones, but do they make money in mobile phones? It's very, very limited. The ones who make money in mobile phones are these ones, Google, and of course Apple. All the others have a tough time. Maybe Huawei is on the way to gaining some interesting performance. So this leads us to a situation where we have to understand that actually technological development today is very much conditioned by the existence of platforms or ecosystems or whatever we call them, and they also lock us in. They limit what we can do. And to clarify this, of course, we also need to know a little about technology performance, because, as I said, we often work in one paradigm, both in terms of the business, but also in terms of the technology. Do you recognize this? Have you seen pictures like this? Yeah, most of you have seen. This is how we normally say that technology develops over time. It's not really true. It's actually a function of effort, not of time. But normally these are very correlated. Performance, initially, we have very poor performance. If we look at the cars I showed, they were not very fast, they were not very safe, they were not very environmentally friendly, and so on. Well, some of them perhaps were. It takes a long time before we reach a good performance, because we actually don't know what makes the difference. But once we get the parameters right, we have a very rapid increase in performance. And then we run into the limits of physics. We cannot go faster than the speed of light. We cannot split things up to any extent. I mean, yeah, we are down to very small particles, but anyhow. There is a limit to most technologies. And what we then see as researchers, and as researchers, it's always easy. You look backwards in time, and you can say, yeah, that one didn't work. We can actually see when a new technology actually took over after another one. Of course, if you are sitting in this, which all of you are doing, you don't know exactly where you are. But with a historical perspective, in retrospect, it's always easy. So what we see is that if we take boats, for instance, transportation of water, we started out with carving out a log and paddling. Then someone came up with a brilliant idea of putting a sail on the boat. Then someone came up with the idea we can have a steam engine. Someone else came up with the idea that we could have a diesel engine. And then we could have a turbine. And let's see what happens later on. So these technologies, they actually take over after each other. And sometimes we see possibilities to extend an earlier technology. And we call that the sailing effect. And I think the car industry today is a good example. Hybrids. That's a way of extending the life of a petrol engine, really. And if we look at the leaders there, Toyota, and initially it was Honda, it's interesting because most likely Toyota put a lot of effort into hybrids to gain time to actually develop fuel cells, because they didn't believe in electric vehicles. Now maybe they are revising that idea.
may I, before we go further, can you please go back with
Yes.
that?
Which one?
No, back
That one.
yes. What's important to remember when we're looking at these S-curves here, we're talking about the performance here.
Yeah.
And when we had the example of the Hasselblad cameras, for example, I mean, it was the image quality that was the performance dimension that they were competing with. And the question is, if we then come up with new technology here, which creates inferior image quality, how come that they can continue and in the long run overtake the traditional image of the cameras and go on? How can that happen? Where do they get the energy, the business case, that when you see that the performance here along this dimension is poorer? Tell me that.
That's a very, very good input, Anders, because actually we are maybe fooling ourselves with this graph.
Exactly, that's my point. So please enlighten us.
I will come to that. I have a picture of that later, but that's okay. Let's start that discussion here, and please feel free to join in. Performance here is tricky.
Because performance can be different things, right?
Performance can be different things, and performance can change over time.
Exactly.
And that is, of course, if we go to the examples that Christian gave you, image quality here was Hasselblad's main thing. But actually the ones who liked the digital cameras were the ones making catalogs. Not the wedding photographers who need a good image quality, but the ones making catalogs, where basically as long as I recognize what it is, it's okay in a catalog. Whereas digital images and digital photography has a lot of other performances that are superior to traditional film.
Yeah.
For instance, the possibilities to, the cost of taking a photo, the possibility to store a photo, the possibility to send or share a photo, the possibility to manipulate a photo. All these things are great, I think, for me, given that I'm a very poor photographer.
So that means that we prefer other properties and other dimensions. And I have started to change this picture a little bit, which I think is very brave because this is so established. But putting on another y-axis here, representing the other dimensions, to make it clear that we have changed competing area.
I mean, we can take the examples we just talked about. If we take the phone and Nokia's phone, of course, Nokia thought that their phone had a fantastic performance as a phone. Just voice, if that is what we use it for, and maybe SMS. But then suddenly we have a phone that has a lower voice quality or sound quality. Connection is not so good, the antenna is not so good, but I can do tons of things and I can have fun with my mobile phone. That changes everything. If we take cars, the performance there has probably been a mixture of things. But suddenly now, if we are talking about environmental sustainability as a performance, I mean, just emissions, suddenly this may change everything. We may accept that there is limited range. That convenience, we can live with that. The lack of convenience, we can live with that if we see that actually we are harming the environment a little less. Not everyone is convinced, but more and more people are convinced.
Does it change also that, just using that example, so the electric cars, some people say no emissions, it's great, it's wonderful, but how do you produce the electricity in the first place? So
that is okay.
you're switching.
We don't have that debate in Sweden and Norway, given that we actually have a lot of electricity from water. In Sweden also for nuclear, which we can of course debate how environmentally friendly is that. But suddenly it has become, because the important thing now is of course CO2 emission, we say, instead of having problems for thousands of years with radioactive waste. So yes, I think we should debate that, of course. However, if we see in some countries it's not really an issue, but in many other countries, I mean, if you burn coal or oil in order to generate electricity, what's the game? We can, of course. And I think there's a point taken. Now, if we look at not only the supplier side, but the customer side, we see that actually innovation is diffused or adopted also following certain patterns. So just like we talked about this, that we see these certain patterns in industry and that we see these developments in technology, if we look at the customers, how they behave, we will also see certain patterns, which of course is extremely important because they are in the end the ones who change the industries. And this is actually a very, very well-researched area. I'm in the field of innovation, and actually the first studies of innovation were just looking at adoption. How do people actually accept or not accept new things? And a lot of studies were in the US, based on farmers, how they actually changed the crops they were using. New types of corn, for instance, do they use it or not? And that also led us to a lot of ideas about how innovation spread throughout society. And the first simple, very simple ideas here were, it's epidemic. It's like diseases. When suddenly we see innovation somewhere, and of course, if we look at farmers in the US, you have two farmers with land next to each other. One is using a new type of corn, and suddenly the neighbor says, shit, he's got twice the harvest I got. And then you go there and ask, why do you have twice as much corn that I have? Well, different kind of crop, different kind of seed. So, of course this happens. Then we have made more sophisticated, saying it's not always like that, because people are actually different. We have innovators and imitators. Some people are keen on change, they like development. Other people are reluctant. They will wait and see. And then, of course, we see that people need different stimuli to take action. And of course, they have different ideas of what is good and what is bad. They have different conditions. What is the value of this? Some people perceive that this is valuable. Others say, why do I don't need it? No value whatsoever. Of course, it's not so simple that it's only about the customers, because we as companies, supply side, we can also push this. We can, of course, try to make clear what is the advantage of an innovation. We can make sure that people get information about this, because if they don't know about the innovation, how should they adopt it? We can take away barriers to use. That is what we're doing now with electric cars. Maybe we have to charge them. Of course, then we have to build an infrastructure where you can charge things. And then we can actually get a lot of feedback from them. And what we see is also here, we get this pattern. That initially it's moving very, very slow. New things take long time to actually convince. And that's of course logical, we don't see them a lot. When we start to see a lot of electric cars, we will probably consider, should I have an electric car? If I never see one, I will not even think that idea. So there is this exponential development, but of course, we only have 100% of a market, and maybe we don't even reach that, very few do. So we get this pattern.
So this is the explanation why good stuff takes such a long time before they have an impact.
Of course, we should, of course, be honest and say today it takes a shorter time because we get the information very rapidly.
Yeah.
But still, maybe we are not convinced by things we see indirectly. But of course, this is probably steeper now. Probably this one is moving like this.
Yeah. On the other hand, we get more information to consider and evaluate. So
that's it. Maybe more tricky to make the right decision.
Yeah.
Then, if we are concerned about making a decision or making the right decision, it may take different times. Now, if we would like to understand this and talk about some simpler factors here, some very basic things, the factors influencing this diffusion is, first of all, of course, how much better is it? The relative advantage. But then we have other factors. One is this, compatibility. And of course, here we realize that in a society where we have more and more platform solutions, this becomes more and more important. Then, the more complex things, the more difficult it is to convince them, our customers. And another thing is, of course, if they can observe it directly or even try it out. And this is, of course, something we see today, that we often try this thing here, trialability. If we can get people to try it, they will be convinced. And then normally that means we have to sell it in a new way. A classic example here is of course the Xerox machine. If we go back to 1958, the first copying machine making copies on regular paper. I shouldn't use that word because if someone is from a paper industry, they will kill me. It's copying paper and it's the finest grade of paper and so on. And I mean, until then we had blueprints. And suddenly we have this new machine that can make copies on regular paper. That was in 1958. It was a company called Hallowed. And actually, they tried to sell it at $2,000 a piece. You can imagine in '58 how much $2,000 is. That's a lot of money for a copying machine. Especially as the traditional ones, the ones making blueprints, cost $300. And companies actually didn't make a lot of money from selling the machines. They made money from selling the liquids, the substrates that you use to make these blueprints. So they tried actually over and over again to convince people that this was a good machine. But no one dared to pay $2,000 to try it out. And this, making a very, potentially very long story very short, what did they do? How did they solve this? They couldn't sell it. At $2,000, no one wanted to try out this new fantastic machine. They changed the business model. They actually introduced the leasing. So the leasing conditions were, you rent this for $95 a month. You can cancel it on a 15-day notice. That means you risk $50. But, of course, they also had this inclusion that actually you paid 1 cent for every single copy, about 2,000 that you made in a month. Most offices made 10 to 20 copies a day. Only 10% of the customers made normally more than 2,000 copies a day. Actually, users went crazy for this. They released the machines, they started using it, and they averaged 2,000 copies per day. So with this business model, Xerox went from being a $43 million company, Hallowed turned into Xerox, it was a change of name, into a $2.5 billion in 12 years.
How much did you say?
$2.5 billion. So from 43 million a year to 2.5 billion in 12 years. 41% growth in average, and then we know percent on percent, that's always an interesting calculation, no matter on what side you are. So this is an example of how we can increase trialability. And observability, we talked about that. Now, going a little more in depth here, customers are different. This is a categorization by Moore saying that basically we can see 5 types of customers. We have the innovators who love technology, they can even develop it themselves, and they are great if we have something that is not really finished. Let them play around with beta tests and prototypes and so on. Then we have early adopters. These are normally visionaries. They are really interested in new things that can change things completely. They are often willing to pay high prices, but they have very specific demands. Then we have a majority, and it's split in 2. We have early majority, they are pragmatists. They want to improve what they're doing, and really important, they always want reference cases from other pragmatists. They don't listen to these. They know that these people, they love technology, so they will say everything is cool. They are reasonably price sensitive. Then we have late majority, very conservative, looking for complete simple solution. They don't want to touch it, it should just be plug and play. Very price sensitive. And then of course we have also laggards. Very afraid of new technology. If they really have to, they will accept it, otherwise they will stay on. Now the problem when we deal with innovation is that, of course, we see here we have initially we can work with innovators, then we can convince early adopters, and then we should move over to the majority. But what happens is actually that there is a gap at Chasm. Some of you may have read this book, Crossing the Chasm, by Jeffrey Moore, really good book. Actually, it means that the big problem is not here, it's not here, it is to jump this gap. Because as I said, early majority, they only want references or recommendations from other early majority. So what you have to do normally is, first of all, realize that what works for early adopters will not work for early majority. Normally you have to rework a lot of your product in order to get some reference cases here, and then it can start diffusing, spreading. And then we can move on. And this is something especially for startups, which is normally detrimental, because they start out here, they experiment with someone who really likes their stuff, and then they find a few reference cases, and then they say, now, let's go. And all the money pours in. And then, after a couple of months, or half a year, or 1 year, they realize they're not selling anything. Because everything is set for selling to this market. But the interesting market is, of course, this one. And then they have to go back, redesign, refine their offer, and very often, unfortunately, they don't have enough money for that. And they go down the drain. And I know that you have spent a lot of time working with your core competencies. Extremely difficult, because it's normally not one single thing. It's normally a bundle of things. And that's how we often define competencies, a bundle of resources. And of course, we can have very different competencies, core competencies in firms. I mean, core basically says that they are more or less a little more unique and very valuable to us. But competencies can be an aggregation of very many different. I can give a few examples here of some companies who actually had some kind of competitive advantage that was based on some competencies, often very closely related to technology. Let's start with this one, the power grid. That's a very simple case, because basically it's a resource, not a competence, that makes you unique. Because everyone understands we don't need X number of power grids, we need one. And in Sweden we have one, it's actually owned and run and controlled by 3 companies. Vattenfall, Fortum and E.ON, but I think one of them has actually handed it over to another company. There are 3 players, that's an oligopoly. It's not a functioning market. And that is of course very interesting for them, because what we have seen now is that whereas the price of electricity has dropped in Sweden because there is a functioning market, the price of using the power grid, getting connected to it, has increased like this. To the extent that now the government has said, okay, this is enough. You're not allowed to increase the prices any longer. There is a scarce resource that becomes then the competitive advantage of those. There are very few businesses like that, where you actually get it for a given that no one can compete with you. Let's take this. Anyone who recognizes what this is? Now, it's Stadskontakt. This is a weird thing. Did a study there many years ago, actually, but this is a very, very old product. It's now 70 or 80 years old. In Sweden, we haven't seen them a lot because we like the ceramic ones, because they're produced in Sweden. But this one, Safe Diffuse, they produced it, ABB produced this in the around 2000. They produced them in Heidelberg, Germany. It's a piece of PVC with very small pieces of copper inside. All the other producers made these in Turkey, in Northern Africa, or in China. And ABB was by far the most profitable one. Actually, for a period, this was the most profitable part of ABB. And it was not only that all other parts of ABB were really performing lousily at that point in time. They made tons of money on making a 60-year-old product in one of the most expensive places in Europe. And it's a piece made up by PVC and copper. Now, what's the explanation behind that? Well, basically, the key to it was automation. All the other companies used low-cost labor to assemble this manually, because we are talking about very small and difficult pieces of copper that should be placed exactly. This group of people had acquired automation technology, Swiss technology, and where they had adapted it. So basically, no human hand touched any of these. And that was by far superior in terms of cost. So they had a completely automated manufacturing and assembly of these in Heidelberg. And then, of course, it's not a problem with a salary level in Heidelberg if you don't have people employed. Sandvik, apparently, we work a lot with Sandvik, but they have never allowed me to see this. They drill these pipes, the tubes. These are non-welded tubes for nuclear power plants. Some reason they want that. It's an extremely hard alloy.